So, hello everyone. Myself Wasim Mushtaq Mir. I am currently pursuing my BTech in Computer Science at B&M Institute of Technology, Bangalore. And I have 4 years of teaching experience on both the platforms, online as well as offline. Now, in today's lecture, I'm going to start with a topic, namely projectile motion or derivation of equation of trajectory from the chapter kinematics. So, without wasting a lot of time, let's get started. So, our topic is projectile motion or derivation of equation of trajectory. Okay. Now, what is projectile and what is motion here? What is projectile and then what is motion? First of all, explain what is projectile here. Okay. So I will I will write the definition of the projectile and will explain to you afterwards. So what is projectile? What do you mean by projectile? When an object is thrown, when any particle is thrown into an air upon which the only resulting force is gravity. Let me write it first here. When any object is thrown into an air upon which the only resulting force is Ty. What is the meaning of this line? Have a look. I will explain to you. When any object is thrown, see, I will take an example in order to in order for better understanding. So let's assume this as ground. Okay. Now I am here. I am going to throw a stone into the air. Okay, like this. After some time, the position of this stone is here. Okay, it covered a distance, so I don't we don't have anything with that. So here, what is the main point here is have a look. So I throw this stone from this point and like this, it moved some distance. Now here, if the stone is here, is there any other force rather than gravity? No, there is no any other force rather than gravity because gravity is pulling it toward the earth, towards the center of earth. Acceleration with the g acceleration due to gravity is always acting towards the center of earth. So here the this gravity is pulling this gravity is pulling this stone towards the center of earth or towards the ground. In short, you can see g is acting here also. If it is fusion must be sometimes here also. Now here g is acting towards downward, sorry, here. This is what projectile is. When a new object is thrown into an air upon which the only resulting force is gravity, because here in this case, only resulting force is gravity. Now, we have motion here. What is motion? What is the meaning of this term motion? Motion means simply when anything is moving. In physics terms, how we can define the motion? Have a look. When the position of an object is continuously changing, okay, with respect to time. When the position of anything is changing, let me take an example of this. So have a look. Here, here is the bus. Okay, its initial position is here. It is at rest. Okay, what is rest in physics term? Rest word is self-explanatory. So it is saying that rest means to stop, to have a constant. Sorry, to be sit at any point. Okay. Now, but in physics term, when the position of an object is not changing with time. Okay. So that at that point the object is said to be at rest. Okay. Now this bus is at rest. Initial position of the bus is here. Okay. Now after some time it starts moving. It starts moving like this. So after some time this position is here, and after some time After other some time, this position is here. So this start moving, this start changing this position continuously. So here in this case, we call it as this bus is in motion. Okay, I hope you got my point. Now we have here is projectile motion. What is projectile motion? Combine a term. Projectile motion. What is projectile motion? So have a look at it. First I will explain I will tell the definition of this projectile motion orally. When an object is thrown obliquely, here the most important word is obliquely. What is the meaning of obliquely? I will explain to you onwards. When an object is thrown obliquely near the Earth's surface and it moved under the constant acceleration. Okay, have a look what I am trying to say. When an object is thrown obliquely near the Earth's surface, it moved a curved path or parabolic path under the constant acceleration. So here, have a look, guys. What I'm trying to now I am going to explain this onwards. So what is definition here? What is definition saying here? So have a look. The projectile motion when an object is thrown obliquely. The most important word here is obliquely. To understand this projectile motion betterly, we have to focus on this word obliquely near the Earth's surface because it is obvious that we are living on Earth. That is why we consider it Earth. If anybody is living on the Mars, then he or she can consider Mars surface. So that is not the case here. So every human being is living on Earth. So have a look. Near the Earth's surface, it moved a curved path. It moved a curved path or parabolic path under the constant acceleration. First of all, I should explain it to you. What is constant acceleration for better understanding? What is constant acceleration? Constant acceleration means here. What is acceleration? First of all, I will tell you what is the meaning of acceleration. Acceleration means change in velocity per unit of time. Rate of change of velocity per unit of time. What is the meaning of this rate of change of velocity? Change in velocity. Have a look. I will explain it to you by example. Okay. So here is this car moving. Okay, car moving. It is initial velocity or initial velocity is denoted by u. Initial velocity. Okay, here the initial speed of this car is zero because it is at rest. Now after some time it start moving and it covers a distance of d. Let's take an example. So now the final position of this car is here. Okay, it is moving continuously. It is moving. It has some velocity. Final velocity is denoted by v. Okay, velocity denoted by v. It has some velocity. Let's for example 10 meter per second. And it covers a distance obviously. And for this covering the distance, this whole distance, it took time of 5 seconds. Okay. Now we have to find the acceleration of this car. How can we find the acceleration? What is the acceleration of this car? So have a look, guys. I will explain to you. See here. See here. Acceleration is denoted by a. It is the rate of change of velocity. Rate of change of velocity is denoted by del v. Del v divided by time. Del time. Del v is denoted by rate of change of velocity is denoted by like this. Now here the initial time is 0 second. Okay. Initial velocity is 0 meter per second. Okay. Now, if I am if I am trying to find now the acceleration of this car, how can we find that? See here, rate of change of velocity is always taken with respect to the final position, final position, yeah, final velocity of the car. Okay, got it. Now, del v, how can we write the del v? Del v is velocity final minus velocity initial upon time final minus time initial. Okay. I hope you got my point. What I'm trying to say here. What is the meaning of del? Del is the change. Del is the overall change that it took place from moving from this place to this place. Let us, for an example, it covers a distance of 10 meters. Okay. For this 10-meter distance, it is acceleration. How can we find that acceleration? Final velocity minus initial velocity upon time final minus time initial. So here, what is the final velocity here? Final velocity here is 10 meter. 10 minus initial velocity here is 0. So time final is 5 seconds. So initial velocity, sorry, initial time is 0 seconds. How can we find that? 10 by 5, it is equal to 2 meter per second. 2 2 meter per second square. Okay, this is the acceleration of this car. So here, rate of change of velocity per unit of time. Per unit of time is acceleration. But now what is a constant acceleration? Constant acceleration means rate of change of velocity. Rate of change of velocity remains same with time. So have a look guys what I'm trying to say for better understanding. Constant acceleration. Okay. What is the meaning of this constant acceleration? Rate of change of velocity. Rate of change of velocity remains same with time. See here, if it is a car, it's a car, okay? It is moving. It has some velocity here, and after some time it moves a distance of d distance, and its velocity will be there somehow. Something will be there, obviously, because this car is moving. That is why. If I'm taking this as initial position, and this will be the final position of this car. So rate of change of velocity remains same. If it is velocity here is 10 meter per second, after recovering some distance, its velocity will remain 10 meter per second. This is the meaning of this. This is the meaning of this rate of change of velocity. So now here, what is the meaning of rate of change of sorry constant acceleration in case of gravity? So have a look, guys. I have projectile motion is what? Projectile when an object is thrown near the Earth's surface, it moved a curved path or parabolic path under the constant acceleration. What is the constant acceleration? Hope you guys got the answer. What is the constant acceleration? Because acceleration due to gravity is same all over the Earth. Everywhere, every corner of the Earth, the acceleration due to gravity is g. There might be exceptions. We don't have to read them. Okay. So constant acceleration. Constant acceleration is rate of change of velocity per unit of time remains the same. Rate of change of velocity remains the same after covering some distance. Okay, I hope you got my point. What I'm trying to say, because constant acceleration is here because acceleration is constant here because g is constant. That is why constant it is moving under the influence of constant acceleration. Now we have some derivations here. Have a look, guys. Now our heading will be derivation of equation of trajectory. First of all, let me tell you some important pointers which are useful to derive the equation of trajectory. First of all, you should know the equation of motion. I hope you guys know. Still, I will briefly explain. First equation of motion is V is equal to U plus AT. Okay. Second equation is S is displacement is equal to UT plus minus half AT square. Third equation of motion is V square minus U square is equal to 2AS. What is V here? Final velocity, initial velocity, acceleration, time. Displacement, initial velocity, time plus minus half A acceleration, T square time. V square final velocity, initial velocity is equal to 2 into 8 times of distance. Sorry, displacement or distance. Mostly it is displacement. So now here, have a look, guys. What I am trying to say here. So now let's draw some coordinates x and y here. So here, if this ball is projectile motion, for a better understanding of projectile motion, when an object is thrown obliquely. What is the meaning of obliquely? Okay, obliquely. Obliquely means at some angle. Let's take this as theta angle. This angle is with respect to the horizontal line and x-axis or y-axis. Okay. So now here, there might be the initial speed of this. There might be the initial speed of this particle. Let's take that as u. Okay. Now, how can we resolve the components? The theta the component where the theta is taken. I have taken with respect to the horizontal is taken as cos theta. What cos theta? The theta or the line on which the theta is being formed or is being considered is taken as cos theta. So here u cos theta. Here it will be for vertical position it will be u sin theta. If I have took angle with respect to this, then this will be the u cos theta and this will be the u sin theta. But understanding here, we are saying as this as u cos theta and u sin theta. Now, what we have here? Acceleration is if let's say let us for an example the position of this particle will be here. Acceleration is towards downward. Sorry, downward. Now let us resolve these components along x-axis and y-axis. First, along x-axis. So here what we have along x-axis. What is the displacement here? X. Let's take as x. Let's take as x from equation of motion from second equation of motion. What we have? S, or we can say it as x. Okay, is equal to u initial velocity along x-axis time plus minus 1 by 2 acceleration a will be d. So a t square. So here What is the x? Sorry, it is not multiplication x actually here. Okay, so here, have a look, guys. What is the acceleration along y-axis? Sorry, x-axis. Obviously zero. Why? Because there is no force. That is why the acceleration along x-axis is zero. So this is very important point here. Along x-axis, the acceleration due to gravity is zero because there is no force. Force is acting only downward. Sorry, on vertical line, on downwards. Okay. What is the velocity along x-axis? Ux is equal to u cos theta. Substituting these values in equation number this. In equation number first. Okay. Now x is equal to ux is u cos theta. U cos theta into t. This will be zero because acceleration is zero. Zero multiplied by zero is zero. Zero multiplied by anything is zero. Okay. Now let's resolve this. What gives us? What are the benefits of this equation of trajectory? Because it gives exact position and future position of the particle. It gives the exact path where the particle is. This equation of trajectory has some benefits because it gives us exact path. It gives us the exact path of a particle. Okay. Now what is this all about? This gives a relationship actually. Relationship between x and y components. Okay. Basically, this equation of trajectory gives the relationship between x and y components. Okay, so if it gives, because it is already mentioned here, because uh, derivation of equation of trajectory gives the relationship between x and y components. So there will be no other variables here in the equation of trajectory. Yes, am I right? Yes, absolutely right. So let us eliminate the values of u and t here for future purpose. U here will be x upon cos theta into t. So what will be the time here? T here, t is equal to x upon u cos theta because there will be no t and u components in the final equation. Now let's resolve this along y axis. Okay. Now what is the acceleration along y axis? Is g. Let g. Will this g be as negative or positive? See guys, sign conventions are very important. If you have that clear concept of any problem, if you are doing any problem, if even if you have clear understanding about the question what the problem is saying, still if you use the strong sign convention, then your answer will be wrong. You will not get the right answer. That is why sign convention is very important. If you here, if you take upward distance as positive, then you must have to take downward distance as negative. So here, let's take an example. I will take this as negative. Okay, negative g. Okay, what is initial velocity along y-axis? It is u sine theta. Okay, now here we have s along y, or we can call it as y is equal to u along y t minus 1 by 2 g t square. So here, what we have y is equal to u along y-axis u sine theta. So here, let us eliminate the values of this t. Here we have the value of t. This will be the a or this will be the b equation. Okay. So from equation a, substitute the value of t here. What will we get? Multiplied by x upon u cos theta. Okay. Minus 1 by 2 g is as such. What is the value of t here also? X upon u cos theta whole square. Okay. So have a look. This is only the mathematical part, nothing else. Y is equal to u. This u and this u will get cancelled. So let me change the color of the pen first. So this u and this u will get cancelled. Sin theta upon cos theta is tan theta. So here is x tan theta. Okay, y minus 1 by 2 g is as such. X power 2 is x square upon this. This 2 is for whole this term. Okay, u square cos square theta. Okay, I hope you got my point. So what is this? Y is equal to x tan theta minus 1 by 2 g x square upon u square cos theta. What is this? Is there any other variables rather than x and y? No, because these are the thetas and we have to take these thetas as what the values will be in the problem. Okay. These values will be mentioned in problem or oh sorry. So what we have here is so this is the equation of trajectory. Okay. I hope you got what I'm. This is the equation of trajectory. Thank you very much.